Okay, I don't know why this is, okay, there we go. All right, let me move you guys around a little bit. Hi, I'm Sharon Libby Irely, and we'll be introducing to you to our big passive project here in Seattle, Washington. Our client, DESC, is an affordable housing provider here in Seattle, and Hobson Place, named in memory for their former executive director, provides 177 units for those in critical need of housing. The south phase of the project is our focus today and is almost 93,000 square feet, 7 stories tall, with a mixed-use program of a medical clinic space below the residential floors. It's located in the heart of Seattle and not far from downtown, so a very urban setting. This is a little bit about us at Walsh. I started at Walsh in 2013 as a quality manager, and after a short decade in architecture, I am now Walsh's quality director with a team of 4 quality managers and 2 enclosure superintendents across our Washington and Oregon offices. Our quality program started well before my time, establishing a collaborative approach to enclosure design, documentation, and execution in the field. This process is implemented on all of our projects, not just the passive house ones. And I'm proud to say, with this collaborative approach and careful attention to detail, we're seeing many of our projects edge closer and closer, or even achieve passive house performance on several fronts. And Greta, do you want to introduce yourself?
Yeah, so to clarify, that crazy letters after my name is pronounced Cheltbait. It rhymes with shark bait, if that helps you remember it. So I'm Greta Cheltbait. I'm a senior project verifier at Evergreen Certified. As Beverly mentioned, I've been with them for about 5 years and had a background in architecture and then at Habitat for Humanity. Evergreen Certified came about in the Great Recession as a way to actually help market our builders' projects so that they could sell them when there really wasn't much to sell. We verified some of the first passive house projects in Seattle and Washington State. And we manage actually over 300 builders currently of projects with varying size and certification types. We provide on-site quality assurance inspections, as well as diagnostics testing to meet both code and certification program requirements, and are verifiers and raters for a multitude of certification programs.
All right, thanks, Greta. So Greta and I are just part of a larger team, and that we are happy to note had a majority of female leads for the project. Also, the core team of Walsh, DESC, and Runberg have more than a decade of experience working together, which was definitely a benefit when approaching an ambitious project such as Hobson Place. There were many aspects inherent to both commercial, larger scale construction in general and Hobson Place specifically that really challenged some passive house measures. And we tried to summarize and group those into as few F words as possible: function, funding, and form. And now keep in mind that not all F words are negative. These are really what made the project possible and what it is today. The function, starting with the program, presented some unique challenges to passive house. The building houses a behavioral health medical clinic at floors 1 through 3 and 92 apartments on floors 4 through 7. Each use required different needs for access, circulation, safety, utility demands, and other stuff. We will get into the whys of this in a couple of slides, but passive house was applied to only the residential floors, levels 4 through 7. And what this decision created were many overlapping and interlacing volumes affecting the passive house boundaries, mainly the stair and elevator cores, as well as mechanical shafts going to the garage and to the roof. Hobson Place South is connected to the north face building that you can see on the right-hand side of this slide, which we completed for DESC in the prior year. And that connection had implications to the passive house air barrier, as well as resident needs for circulation and access to all the different services. And there were additional performance goals in addition to passive house, including operational goals that are typical for all DESC projects. The residential population here is at home for most of the day, and therefore the apartments need to be durable and well ventilated. And while these goals sound perfectly aligned with passive house, the operating and maintenance of the building and mechanical equipment is typically done in-house, so equipment selection was very carefully approached. Affordable housing also has limited resources for ongoing maintenance, so the systems as well as the materials need to be durable. Hobson Place South is a demonstration project for a local utility, Seattle City Light, and an advocacy group called Exemplar Buildings Programs. This pushed the project to achieve an EUI of 20 and to be all electric. The biggest changes in reaching those goals were the use of hot water heat pumps and for domestic hot water rather than gas boilers, and the 40 kilowatt PV array on the roof. which is a great introduction to our second F, funding. 2 funding sources became available for the project specific to affordable housing that allowed DESC to pursue a higher performance path. The first was a state program for ultra high energy efficiency buildings, in which FIAS is a path to compliance. The second was Seattle City Light Demonstration and Exemplary Buildings program that I mentioned before. The design for Hobson Place was largely completed before FIAS certification and the SCL program was committed to. So measures such as increased wall and window performance, hot water heat pumps, balanced ventilation with improved mechanical equipment were added after the bulk of design was determined and those costs were tracked. The incentive funding covered all passive house and SCL adds plus some soft costs and inherent performance goals. It's important to note that while we have seen great cost efficiencies realized when passive house is committed to before and during the design, this building being in Seattle with some of the most stringent energy codes in the country and serving the needs of affordable housing, think durability, low cost maintenance, operations, healthy air, and materials, really raises that baseline. And we'll talk more about challenges of applying passive house to this project, but note that we weren't starting with a poor performing building. This graphic is a great one to quickly understand what it takes to achieve the goals established by Hobson Place team. Provided by a local housing advocacy group, HTC, a couple of years ago, this illustrated the main pushes in getting to in the EUI of 20 really need to be with the domestic hot water supply and space heat needs, which really translates into the building enclosure for our climate. We like to think of Seattle as a special place, but it really is for the latest energy codes. And our current codes, which is one cycle beyond this building, now require many of those measures, such as ducted balanced ventilation with energy recovery, a better enclosure, domestic hot water heat pumps. And essentially, when you look at the difference between the code minimum and the passive house, that gap is narrowing and the cost premium really will be narrowing as well. Our third F word is form. A significant portion of the building was not included in the passive house boundary. So that would be the parking garage, the clinic spaces, and then phase 1. And all of those non-passive house spaces have connections to the passive house enclosure. And in the case of the mechanical shafts serving the different uses really cut through those spaces. Included in the passive house enclosure are the 92 residential apartments in the 4 stories of wood framing over a 4th floor concrete slab. Now the form and plan isn't simple either, and one could say, well, why not make this a little easier and make it more of a box? In affordable housing, unit layout is very important. The design needed to accommodate as many units as possible, along with the service spaces needed on each floor, and a simple box doesn't typically allow for that. And here the H-shaped floor plan was suited the unit layout and the owner's needs, and then again, that was determined before passive house was decided to be applied to this project. And here's another look at those stair and mechanical shafts in the building. And so these are the included passive house enclosure, or spaces that were included in the passive house enclosure as they serve the residential spaces. So you can see their shape varies a bit as they go through those non-passive house floors at the garage and the clinic spaces. So each of those boundary walls had to be detailed for air tightness and thermal boundaries in cases where they leave the heated portions of the building. So Orchards at Aranco was our first, for Walsh anyways, our first passive house project. The building is 3 stories of passive house residential spaces over a slab on grade. And as you can see here, is pretty open at the exterior walls, allowing for access via man lifts throughout the duration of construction. The exterior wall air barrier is sealed plywood sheathing with tape seams, and mechanically attached WRB was applied on top as well. We found that our past passive house experience served us well in many regards, but it was also very different than Hobson Place. So as mentioned before, the passive house spaces at Hobson Place are the upper 4 floors. And access to the elevations was via scaffolding and a crane, as there's limited perimeter space. You can see the orange flags that mark out the power lines to the east along here. And so that was our do not cross line. And then on the west, there's a very small alley that we had to put a job trailer in. And the north side is connected to another building. And so the south side was really the only one that was open, but we could also not block the street. Because the building was fully scaffolded, the sequence for install the exterior wall materials followed the scaffolding 1 elevation at a time around the building. And this made it a little challenging to plan for a pre-test of the air barrier prior to cover, so we decided to use a self-adhered membrane for the air barrier and WRB to help with that timing and sequence. There were a couple of curveballs with the plan sequencing that I'll get into a little bit later. So we recognized the differences and applied our experience where things seemed applicable and adjusted based on that experience where the design and site conditions diverged from what we had done in the past. And as I get into more of the details, I only have time to share a few. I'll let you know what was planned, where things went a little differently, and what we learned. And how did we accomplish it? This big of a passive house project, a large mixed use building. I'll take you through some of the key project details, how we adjusted for the larger scale construction, some of the curveballs, teamwork required, and lessons learned. So starting at the roof, we had an assembly with R50 insulation and the vapor barrier serving as the air control layer. And we needed to reduce penetrations in that air control layer, so we were able to get the ductwork for the passive house areas of the building within the enclosure. And here you can see a great comparison of the north and south phases. And you can see the ductwork on the north phase that was all exterior, and then on the south phase, there's hardly any ductwork at all. So these are our big ERVs and not much ductwork. I think there's a little bit up here, but that was actually for the clinic spaces. We started our air control at the roof perimeter, accomplishing that tricky roof to wall connection with first pre-stripped vapor barrier that laps over the wall air barrier. Then the platform or parapets are platform framed on top. And this is fairly typical detail for us that we try to make happen on every project. Then the rest of our roof vapor barrier and air control was hot mopped and tied into that peel and stick at the perimeters. All curbs were then framed over, just like the parapets, so we can maintain the continuity of the air control layer. We did have one section of the parapet that couldn't be framed for structural regions that we had to adjust for. So here you can see the two different structural details and then how we adjusted the line of air control in the field to go up and over this parapet and still connect back down to the roof. And this took teamwork from our design team and installers in the field to ensure that all transitions were addressed. Then any penetrations in the roof vapor barrier and air barrier were sealed and insulated. And you can see here the mechanical duct stub outs that were in place well before any mechanical equipment was on site, so we could detail them with the other air barrier materials were still accessible. And this is a great example of how the typical sequence had to be adjusted to ensure detailing could be accomplished. And those stub outs were also important to have in place early for interior detailing. These images show the ERV trunk lines that were brought inside the passive house enclosure, fitted into the ceiling space of the 7th floor corridor. That was done by using car decking to skinny up the framing and 1 hour rated ceiling space for the ducting to be housed. And then our design team worked with the jurisdiction to allow 4-inch ducting into the units, which eliminated the requirement for fire smoke dampers that would have added significant cost. So that was a win on all fronts, really. The air barrier at the north wall was actually installed with the north phase building. There was a lot of planning for this wall since it was to be in place months before the south phase was even out of the ground. We used a silicone liquid applied air barrier that could be left exposed to the elements in UV. Then tie-ins at the slab, shear wall, and other transitions were carefully planned ahead of time in a series of diagrams like this one. We worked with the design team on several options for detailing at each of the conditions, so we'd have those options as we moved into south phase construction, and that was before it was even fully designed. And here is what some of those transitions looked like. Silicone transition strips were used to connect the concrete of the south phase to the silicone air barrier at the phase line wall. There were also wall-to-wall connections like this one that had siding held back a few inches in the north phase so that we could tie in once the south phase building was in place. And most of our planning worked out for these details. I think we only had one small section where we actually had to remove some siding to access the air barrier and reinstall it. And the south phase building is 1 story taller than the north, so there was a roof to wall connection too, and you can see our installer standing on the parapet top of the north building, connecting the air barrier into the roofing materials, then again, the roofing vapor barrier of the south phase. The exterior walls were 2x8 wood frame to allow for R30 blown in bat insulation. This wall assembly is kind of a sweet spot for thermal control in the Pacific Northwest, allowing for an increased R value without going to exterior insulation, but still avoiding that condensation risk within the wall cavity. Blown in bats should be installed to the manufacturer's stated density, but how do you check that? One manufacturer makes a density gauge just for that purpose. However, it comes at a cost and oh wait, it'll need to be shipped up from California. And by the way, we're sure to use the manufacturer's scrim because that could affect the density reading on the gauge. So, well, due to supply chain issues, the insulation manufacturer scrim was actually not available to us. So another one was used. And this didn't come to us as a surprise, though. We knew of supply chain issues that they've been pretty common over the last 2 years. So we had actually had the insulator submit on a few manufacturers' products because no one knew what actually was going to be available when it came time to do the building. So we measured the density of the blown-in bats the old school way, and this was something we actually did at the Orchards project as well. We cut out a cubic foot and weighed it. We did this check in a few places on each floor before we had Greta do her checks, and that way our insulator could make the adjustments as they installed the material versus having to come back and slow down any subsequent trades. One curveball that came our way was that we had a few areas on the 7th floor in the roof penthouse that had 2x6 framing. R30 blown in wouldn't fit. So once we identified, which was pretty early, this issue, our design team and Passive House consultant were able to check the model and approve the R23 blown in bat for those walls. But however, once the crane was removed, there was no way to get that blowing machine back up to the roof. So a little bit of a catch-22 there. The crane was utilized to hoist that machine to the roof, which I hear is about 2 to 3 times my size, and no one wanted to lug it back up the stairs. So then the roof and the walls were insulated moving down through the building, a little bit easier to move that machine around. And then the crane was actually removed. It was located in the stairwell, and the crane was removed in order for the penthouse framing to be completed. And by then that blowing machine was actually not on those upper floors at all anymore. So sequencing is a huge part of every project, but for larger scale projects, it's crucial as sometimes not an option to hold off another trade or bring equipment back or close off access to the areas of the building. But this stairwell was going to be needed, or was going to need to be insulated with bats and by hand. Working with our insulator, we found that 2 layers of R15 compact bats would fit in a 2x6 wall. However, the compression of those bats reduced the insulative value down to R22. But since the blown-in was only getting us to R23, R24, Passive House team was okay with this approach. And it was in a very limited area, so it didn't have much effect on our model. It was a great example of how working together as a team provided a feasible solution. And now the install, though, was a whole nother ballgame. You all know what a stairwell looks like, so this picture isn't a much surprise. And that high wall over the stairs that go down is very difficult to reach. And that led to a non-grade 1 install. So you can see the insulation layers pancaking in this area here where it was hard to reach. And also we have structural blocking taking out large sections of the installation in its entirety. So in larger scale construction, the 2 things that override performance goals are always safety and structure. And this is a perfect example of both of those things. This stairwell is serving as our second point of egress for the building, so blocking it off was not an option. Uneven ladders that are not permitted by our safety standards, and scaffolding would have been an extra expense. So the insulators were able to correct this with their proprietary extension pole tool, but it wasn't simple with the limits on access. And like safety, structural blocking is not optional either, so that obviously had to remain in place. It took teamwork from the Passive House design team to our suppliers and installers in the field to get these walls insulated with the best product and installation as possible. Now, our windows are all triple glazed with values of 0.18 or better. The interior perimeter air seal was made continuous at all 4 sides, which is typical on all of our projects, and each one QC'd by our field enclosure specialist, or what we call our skin doctor. If you notice the reddish hue to the framing, that's fire treated lumber required for type 3A, which is what we had here for the framed portions of the building. We had a slight adhesion issue, but we're able to work with the air barrier manufacturer to find a couple of solutions to ensure everything was well adhered. When we started planning and budgeting for the exterior wall air barrier, we looked to our experience and tested results. And these were our top 5 projects for air tightness. Not all of these are certified Passive House. 2 of them are, but we have accomplished other buildings that are within that range. So these were great experience. And as you can see, 3 of 5 used sealed sheathing for the air barrier. We actually decided against that approach at Hobson Place since we did not have the open ground access of those previous projects. We also had an install sequence that was per elevation rather than per floor. So we need to be able to tighten up the timing between the installation of the air barrier, WRB, and windows with 1 trip around the building. That and a few other reasons led us to the decision of a fully adhered membrane for the air barrier. And now this picture is what we had in our minds during pre-construction as an installed air barrier ready for pre-test. But while during scheduling, we found that our air barrier actually needed to look like this, with all the windows, flashings, and other transitions, terminations, and penetrations fully detailed in order to do that pretest. And we had planned for that in the schedule. However, when the flashings were delayed because of a material shortage, the air barrier started to look like the picture on the right with unfinished laps. And our carefully planned sequence dance around the scaffolding and crane schedules with multiple installers just got a little tripped up. And these are pictures of our upper floor access point from a scaffolding scare tower. Access and egress are safety requirements in commercial construction, and as noted before, they take precedence over all else. Before the stair tower went in, there was no way to reach this area of the wall, and since it's at a floor line, there was not a safe way to pre-strip the area, especially with flashing needing to be integrated all at the same place. So this was an area of the air barrier that we knew would be incomplete at the time of our pretest, but if that was really the only thing that we had incomplete at that timing, we would have been okay. And like you can see here, we have a missing flashing saddle that caused this lap to be open and unfinished at the time of our pretest. And that's right at that transfer slab. And speaking of the transfer slab, if you recall the passive house boundary diagrams I showed earlier, this is the bottom of our passive house enclosure at the top of the clinic space. We had several different transitions at this level 4 slab. As you can see here, overhangs, soft courtyards, etc. And with each of these transitions, there are multiple installers to manage, from metal framing to insulators, roofers, waterproofers, and siders. From the inside of the clinic, there were also over 100 penetrations in the level 4 slab to get utilities between the residential and clinic floors. Each one had to be sealed and the details verified with material manufacturers as compatible. And we planned a pretest to review the installed air barrier prior to siting. And we did this at Orchards projects with a lot of success. We were able to use infrared and smoke to identify any breaches in the air barrier and then prioritize the correction at those. But at Hobson Place, we had a few challenges. The elevator shaft walls were accidentally unloaded from the train in Chicago, so only some of them made it to the site on time. Mechanical running into some of the shafts were delayed, which caused a delay for the drywallers doing the shaft walls. And this resulted in some very large isolations, as you can see here. On the left is our elevator shaft. And then on the right, you can see our project engineer attempting to keep an isolation in place as we turn the fans on. So for the pretest, we actually ended up isolating the passive house floors a little differently than along the passive house boundary we looked at earlier. And since the elevator shaft was open, we instead tested each floor individually. And the lessons learned from our pretest were definitely not what we expected, but not all for naught. First thing, kind of obvious, we learned to build better isolation walls. This is the designed opening between the north and the south phase buildings, and plywood with tape seam and spray foam edges works so much better than just plastic. We also learned in our pretest to trust ourselves. Even though we were not able to see the leaks with infrared due to scaffolding and warm summer temperatures, we could use our own eyes and hands to identify those leaks and the unfinished detailing. Our site team was all hands on deck during the test or the pretest, with people stationed throughout the building on the interior and exterior scaffolding, reviewing the air barrier while fans were running. And we were able to identify the areas that needed improvement and work to prioritize those in the schedule so that our siding work could continue and we wouldn't have any delays. And with that, I'll pass it over to Greta to talk about our certification process.
Wonderful. And Sharon, I'll just have you click the slides and I'll just give you a holler so you don't have to transition that way. So the realities of the certification process for Big Passive is complicated. FIAS actually encompasses FIAS Plus, which has many co-certifications. And this project in particular had other certifications linked to the project's funding. So it was a lot to coordinate. Sharon had some F words that she talked about, and I'm going to talk about probably one of the most notorious B words in the passive house community, which is boundaries. So yes, this includes the physical boundary of the passive house envelope, but it also includes scope and communication, testing, environmental boundaries, and knowledge boundaries. So this first one is scope and communication. This requires that the verifier is involved as early as possible on the project to understand who else is on the project team, what their roles and responsibilities are, and what exactly we will need to verify. as Sharon mentioned, this project had a lot of overlap with other certification programs. So by having meetings with the general contractor and other subs that were associated with the Passive House envelope and mechanicals early, we can better determine where there's overlap and how we can share the work and then share those results. Also kind of goes without saying, but could use some reiteration of the importance of establishing structure and lines of communication with the project team. So we were actually hired by the owner's rep, but most often we are communicating and coordinating these inspections with the GC. And we would often reach out to the subcontractors directly to ensure that we had the correct information. So it's learning, that information ahead of time to know who wants and needs what information. Next slide. The next one is the envelope boundaries. So that's, probably the biggest one in terms of the Passive House realm. And as Sharon noted, the sequencing of the project was pretty difficult at times, but we found a lot of success in creating efficiencies from the verification side by overlapping inspections. So for instance, I was able to, when one floor was finishing up insulation, I was then able to inspect the next floor below it for air seal. And then oftentimes by the time that I was done with the air seal, I could go back upstairs and look at the corrections that were made, if any, for the insulation. So this just allowed for, more efficiencies in terms of reports, documentation, and time spent on site. For the next slide here, similar to what I got into, on-the-go problem solving just really allows for, less time spent sending reports back and forth, documenting things. Walsh had a rep from their team who was like their, I think, enclosure specialist is what you had called them. And they walked around with us and oftentimes like an insulation laborer or whoever to fix things as we went. So again, it could just be maybe another round of walks to see these corrections. And then I was off knowing that these items had been fixed. For the next slide here, also testing the boundaries. So as Sharon noted, the volume of what we were testing was pretty complex, with only 4 of the 7 floors being a part of the Passive House envelope, with basically these legs that went down to the parking portion of the building. So we had, we had the ability to tape off some non-threatening areas. So spaces where the Passive House envelope abutted conditioned space at the north phase, and then, at the elevator doors and stairwell doors at the medical facility floors. That shows much of the taping that we did, everything from those doors to the north phase, the elevators, elements that, during a pressurization portion of the test would be blown open. We're able to tape those off, and then things like trash chutes that were basically just connecting all of the floors together. For the last or second to last one here, we did run into some environmental boundaries, specifically the snowstorm that happened at the end of the year. Now, for those in the Seattle area or outside of the Seattle area, excuse me, we do have mountains, we do get snow, but it's becoming more and more prevalent, and often, over the past few years with climate change getting worse, we're seeing worse and worse storms that we are not necessarily prepared for. So there were certain things with the ERV that we had to fly a manufacturer's rep out to help us fix, because there's issues with condensation. So those were, a few hiccups, but ultimately the goal of what Passive House is trying to accomplish is, trying to reduce the effects of global warming so that, we can at least be more stable, so that these types of issues can be, in theory, more predictable. And then for the last slide, something that I think this group will really appreciate is the knowledge boundaries. So I'm sure on this call of, however many, 107 people on here, that there's a huge wealth of knowledge. But sometimes, you're so focused on your particular portion of the job that you're not necessarily thinking about what else you might need to know. So on the left, I am not an electrician. I don't claim to be, but we needed to measure the power draw for these ERVs to be included within the overall WFI model. So working together with folks who are, experts of their trade and being willing to share that information and knowledge. I often think of the theory of the curse of knowledge, where you repeat your job and your tasks and your technical knowledge so much that it becomes second nature, but to someone else, it's completely outside of, their understanding of the world. So just being willing to share that. And I think that's, why Passive House Accelerator has been so wonderful, because it's able to get folks into the Passive House community at so many different levels, and can meet you where you're at and bring you in and get you to be the nerd that you desire to be. So
thanks.
Back to you.
Thanks. And the slide you've all been waiting for, our results. So we completed this project on time and under budget. We were able to deliver 92 affordable homes for DESC, a behavioral health clinic space for DESC in Harborview, which is one of our largest hospitals here in Seattle. We are currently seeking FIA certification. That Greta's handling all of our paperwork. And our whole building air infiltration rate, and this is for the whole building, non-passive house spaces included, was 0.096 CFM per square foot at 75 PA. And then for the passive house spaces, just those residential floors 4 through 7, our air infiltration rate was 0.074. So under what we needed, yay, with all those complexities. And then our average unit compartmentalization rate was 0.1441, which is well below the requirement. And I'll just take a second to brag. With an enclosure area of over 57,000 square feet, Hobson Place is likely the largest building in Seattle, and certainly the largest affordable housing building in Seattle to seek FIA certification. So go team, go. Our lessons learned are early planning really pays. Sequencing is great, and all the planning upfront is very well worth it, but also be flexible, make sure you have an ability to adjust what you think is going to happen. It will change. And then trust but verify. We needed to trust ourselves a little bit more, and we had the knowledge and the expertise in-house that we were able to accomplish this, and we really proved it to ourselves. Test early and test often. That definitely helps understand where you can improve things. And from the very beginning, establish a collaborative team from your design team and your contractor and down to every last installer. Everybody needs to understand the goals of the project and be on board to accomplishing them. It's much easier to move forward in a collaborative way and when everyone's on the same page. And I want to say thank you for allowing us the opportunity to present, and I'll be here for a little bit to answer questions, and Greta, I believe, will also. So thank you.